Now we're gonna prove this famous and excellent result concerning the exponential and a polynomial of the first degree. So we're gonna prove that 1 plus x is less than or equal to e to the power x for all the values of x. So basically we're gonna use the mean value theorem. Okay, there are many other ways to prove this result. One of the ways is that we define a function, let's call it g of t, and let it equal to et minus t minus 1. So we study this function, okay? And we're gonna prove that this function is increasing all the time, okay? So it's gonna be g of t is bigger than 0 for all t in R. Every t in R. This means that e of t is bigger than t plus 1. You can use that one and prove it. But for us, we want to use the mean value theorem to prove this result. So for us, we choose f of t as e to the power t. Okay? So our function in this case is, let's choose 0x as our domain. So in this case, f of t, where x is positive, so f of t is defined continuous and differentiable on this interval 0x. So these are the conditions to be able to apply the mean value theorem. Okay, so since we have these conditions, the mean value theorem let us conclude that there is a c, there exists a c in this interval 0x, such that f prime of c is f of x minus f of 0 over x minus 0, which is x. So f prime of c is e to c, because the derivative of the exponential is the same, it's itself. And f of x is e to the x, f of 0 is 1 over x. Okay, so now what we need to do is we need to do some algebra on c to get e to the power c and conclude. So from here, so that means c is between 0 and x. Okay, since the exponential of x, or the exponential in general, it's increasing. Okay, so we have e to 0 less or equal, then we can use that here, e to the power c less or equal than e to the power x. Okay, so e to the power 0 is 1, e to the power c is this one here. Okay, so it's e to x minus 1 over x less than e to x. Now, since x is positive, we can multiply both sides by x without affecting these less than symbols. Okay, so we have x less or equal than e to the power x minus 1 less than or equal to x to the x. We add 1 to both sides, we get 1 plus x is less than e to the x less than to 1 plus x e to the power x. So this is our result using the mean value theorem. Notice that we get two results. Okay, so we get two results, but the one that we need is this one. Most of the time when you do the mean value theorem, you get something extra. Okay, what does this one mean? It means that if we graph the exponential, okay, and we graph this this line that goes through these 2 points, minus 1 0 and 0 1, so e to x, e to the power x is gonna be above this line x minus 1. So this is a geometric or a graphical proof, but this one using the mean value theorem, one of the most important theorem that we will need a lot. If you want to study calculus, do proofs, you need to know how to apply it and use it in your proofs. For this one here, we can study the derivative and do it very quickly and conclude that e to the power t is bigger than t plus 1. Okay, but the main aim is to apply the conditions, or to get the conditions for the mean value theorem, and choose your function and get this C and see where it's located. And after that, you need to do some algebra, some bracketing basically, to get the value that we need. So in this case, we did all the steps to get this result. Thank you very much.